Okay, so what I'm talking about is some technology that was developed at Elastic and contributed to OpenTelemetry. It's called inferred spans, and it's about combining profiling with tracing. So for those of you who don't know tracing, it's very basic technology. It's looking at the flow of a request running through the system. That can be a distributed system or a monolith, whatever you prefer. So you've got Java application, you want observability onto it, and the common thing, there's traces, metrics, logs, errors. So the trace, metrics and logs, you understand errors, you understand traces if you haven't seen them. It looks like that picture on the right there, which I'll show you a more detailed picture. And what it involves is adding an agent. You can do it in an SDK or manually, but the easy way is to add an agent in with the -Java agent, or it can be auto-instrumented in Kubernetes. And what the agent does is it instruments, it injects bytecode on the application. But it doesn't instrument everything. So some people think, it's like, let me see if I can get this going. Yeah, some people think it's a bit of magic, but it isn't. It's very specifically all the common frameworks that are in use. And when you're developing an instrumentation, you look at the common framework and you look at the entry point of the framework and the exit point of the framework, and you add in essentially a kind of it's a kind of logging, but it's specifically logging in the terms of a trace, a span in a trace. So it's not everything. So if I go over to look at those traces that you saw just in a bit more detail, here's two of them. And this is an app, and it's sending a request to server 1 and server 2. And those servers send their requests on to server 2 sends to server 4, server 1 sends to server 3. And these servers are actually pretty much identical except for the web technology that's implemented. So the top one uses, I think it was Jetty, but it's some standard web technology. And the bottom one used the one that's in the JDK, the web server that's embedded in the JDK. And as it happens, OpenTelemetry doesn't instrument the JDK web server, but it does instrument Jetty. So you see, you get the full trace in the top one. You get to see the request coming in, going to, that's in green, and then in blue going to server 2, and then red server 4. And the bottom one, you don't see any of that, even though it's exactly the same flow, because the instrumentation isn't there for the technology, the web server technology in server 1. So it's something that you'd like to see more. You'd like to see things that aren't instrumented, and that's what inferred spans does. It's a bit of magic. It's a kind of magic. It runs a profiler alongside the application. It doesn't do it the whole time. It's not a continuous profiler. It's very specific and very demarcated. So what happens is that when you've got a trace happening, it will run a profiler just for the threads that trace is affecting, just looking at those threads and see if there's anything taking a lot of time in those threads, and it'll say, oh, okay, this is interesting. These things that are taking time, and what I'll do is I'll create a little span on the trace for that. Does have some limitations at the moment, mainly because it uses async profiler, and those are async profiler limitations. So, oops, now it's demo time. Okay, demo time. Let me go over here. I'm using a Kubernetes cluster. Let me just see, it's got everything running. This is an OpenTelemetry operator, and that's just auto-instruments the application. And I've got 4 example apps running here. And let me just see what I've got here. Let's have a look at the app. So that's the app there. So if you don't know Kubernetes, it's really essentially, this whole thing is just pulling down this one app. And this one app is, let me go over to here. And that's this app here. So it's just an app in a Docker image. And you can see, very basic app. It's just a loop. Up there in main is just looping every 2 seconds. You can see the run call. It pauses every 2 seconds calls method A, and method A calls method B calls method C calls method D, but both method C and method D print out that they're being called, and they also have sleeps in them. Method C sleeps for 10 milliseconds, method D sleeps for 200 milliseconds. It's a very simple app. So let's have a look at that first one that we've executed here. I just started off four apps. So I showed you what this app is doing, and it's just exactly calling that Docker image. And if I look at the apps, the log, it's exactly what you see, method D, method C being executed. What that app doesn't have is any instrumentation, because if I go back to that, there's nothing in here that inserts instrumentation. Now let me just show you the second example here I have, which adds this one thing. It's an annotation, and it's actually a directive to the OpenTelemetry operator. And this bit is the directive. It says OpenTelemetry operator, do something. And what I want you to do is inject Java. And what I want you to do is, to find the Java I want you to inject it, is I want you to look at the DevOps namespace in Kubernetes, and I want you to find the instrumentation, which is called this, and I want you to inject that. So when that happens, it just injects it. It's a very straightforward mechanism. What it does is it pulls down the image for the I can actually show you that. Let me show you the. Let's see if I can find it. It's. Cat. Oh, what have I called? I've called it 0. Yeah, so I mean, this is the instrumentation, and what it does is it says, actually, this is the endpoint that I'm going to send the data to, and what it does is it's going to pull down this, which is an actual Java agent, and in the Java agent, it's got a jar in there, and it's going to pull out the jar, it's going to put it into a shared directory into the for the Docker file, and that Kubernetes pod is going to run the agent inserted into the application. So all very, very well and interesting. And if I look at the logs for that second one, it's pretty much the same. It's exactly what you'd expect. Method B, C, D, and so on. And if I go over to my service map, applications, service inventory, I'm running all three at the moment. So we're looking at example 2. And example 2 is actually very boring. There's nothing of interest there. If we go over to the metrics, there are metrics being produced, but we don't see any traces. And that's because it was back to where I showed you that first example. There was nothing in that technology. If you remember, it's just method A, B, C, and D being called. That's not there's no technology in there. So the agent doesn't know to instrument anything. It just says, okay, this is an application. I'm going to instrument anything that's a well-known framework, but actually there's nothing in there to instrument. So that's why there's no transaction there. Now, what I have for example 3 is there's one bit more is I add in this environment variable here. It's a standard environment variable that's supported in OpenTelemetry by the Java agent. And what it says is, I want you to instrument the method or the list of methods that I include here. And this is the name of the method. This is what I'm asking it to instrument, which is method B, obviously, in that application. So I go over there. If I look at example 3 now, it's a little bit more interesting, because now we're getting some traces, because it's see, test method B. Now we're actually seeing a trace. So if I click on that, I can see that it's a bit more interesting. We're actually seeing something, but we're not seeing very much. We're just seeing method B. And if you remember, method B calls method C, calls method D. Again, the Java agent has no idea that those other things are worth instrumenting. So you don't see them. You only see the thing that you specifically asked it to instrument. And that's true for the frameworks that are automatically instrumented. They will be instrumented, but not the things that they call. Their call stack won't be instrumented. So that's what you'd see with a web service. If I go back to this original one, that's what you saw. What's instrumented there is the get call, and it's tells you it's an HTTP GET, and then you see that going, but you don't see what's happening within those services because there isn't anything else, any known framework that it's using that's being instrumented there. So finally, let's go over and have a look at our last example here. Again, I'll give you the diff. So the diff here is I've turned on this OTel inferred spans enabled. So once again, because it's called OTel something, that means it's a standard name within OpenTelemetry. If it was Elastic OTel, then it would be Elastic specific, or if it's some other company, they'd have their specific one. So this one says, I'm going to just turn on OTel spans enabled, inferred spans enabled. And if I go over here, I'll look at that example 4. And let's have a look at it. And we still see that testing method B. That's the one that's we've asked it to instrument. And if I go in there and I click on it, and we go over to one of them, now we're actually seeing something. We're seeing the underlying call. If you remember, it was method B, method C, method D. Method D was 200 milliseconds. Method C was an extra 10 milliseconds. So it's got the 211 milliseconds, right? Because that's a specific instrumentation. It's actually finding the start and end of method B. But the rest of it is inferred. That's why it's called inferred spans. So what's happening here is it's running a profile alongside the application, and it's taking stack traces, and it's doing stack traces by default every 50 milliseconds, which is why you get this 150. So every 50 milliseconds it sees a stack trace, and then it eliminates everything that's, say, Java core, because that's not interesting in terms of that. It's going to be application specific that you want to see. And it eliminates anything that's moving, that's changing in the stack trace, and it sees the most, the closest to the top that's not changing. And then it says, okay, that's interesting. That's lasted for 3 stack traces. So I've got 150 milliseconds of this method D. That's really interesting. So I'm going to create a span for that and say it's a child of that. And if I go along here, I can also see, there's another one. This one's called method C and method D, because if you think about the 50 milliseconds sampling, this time it's caught method C just when it's in the 10 millisecond, just after it started its 10 millisecond pause, but before it started method D, and then it's carried on sampling, and then it's caught it at the end again, because you need at least 2 samples of method C to see there. So because that's 210 milliseconds, there's some of these that's going to be caught. So it's full visibility into the application with very little overhead. If you don't know, the async profiler has very minimal overhead, 1 to 2%, and you can tune it down by taking more infrequent samples. So that's pretty much it. That's the whole show here, the whole talk, and yeah, it's a little bit of magic that gives you much more detailed visibility into your application. This is technology that we implemented in Elastic. We've contributed to OpenTelemetry, so it's now a standard part of the OpenTelemetry, not directly in the agent. It's a contribution. You can create it as an extension and add it into your OpenTelemetry, or you can use our agent, which does that automatically. So it's our OpenTelemetry distribution just includes it as an extension. That's much more convenient for our customers, but for anyone who uses it. But you can build it yourself. In fact, I can show you. Let me see if I can show you that one. Vanilla with extensions. There you are. If you're going to build your own instrumentation to do that, this line here says, give me the latest version of the OpenTelemetry agent. And this line here says, add in the extensions, which we supply in a Docker image, but you could build yourself and put it into your own Docker image. And that's a non-elastic, if you like, apart from that Docker image, which you can build yourself, version of the OpenTelemetry. And that's it. Thank you very much. Just time for one quick question, yes.
Does it support reactive?
Well, reactive...
I mean, like a webflux in the...
a lot of webflux is instrumented by the OpenTelemetry, so yes. And this is independent of the technology that you're running. That's it. I hope you enjoy the rest of the time. Oh, you can ask me afterwards.